Hi science teachers, welcome to Science Teacher Summer School, episode 10. I'm Kent Louie, and something you may not know about me is that one time when I was younger, I wanted to trim some extra pounds off my gut. So I gave up drinking pop and instead decided to drink fruit juices. Now needless to say, I didn't lose any weight because fruit juices are high in sugar too. I think I may have actually gained some pounds doing it. Now, let's get to work. Today's topic is about setting up your science rubrics, and specifically, the 4-column rubric. Rubrics are not new to science ed. However, they have become more popular since science curricula have shifted towards more skills-based and standards-based assessment. Here in BC, we use a 4-column rubric to assess skills according to these 4 levels of ability, emerging being the lowest, developing, then proficient, and extending being the top level. The problem is defining the different levels of ability. When it comes to setting up rubrics, how can we efficiently define ability levels, especially between the top 2, or proficient versus extending levels? First, don't worry about having your rubric match exactly what your colleagues have. We're all science teachers. We all studied science and know what good science looks like. And chances are, our colleagues are looking for pretty much the same thing from their students as we are from ours. We just happen to word or classify it slightly differently than them. So, don't worry about getting it right. I firmly believe we're all pretty close to each other, and close is good enough. However, I will be providing a sample rubric later if you want to see my categorizing in action. When I start developing my rubrics, I define what proficient is. Proficient is what a student needs to say or demonstrate in order to get an A. For a written test question, the correct answer is proficient. In a lab, proficient could mean, for example, creating a neat data table and taking down the measurements with correct units and significant digits. And according to BC standards, for me, doing everything correctly is second to the top of my rubric. So, what constitutes extending or the top level? To me, extending means a student makes connections from other areas to this particular context. For example, for a written test question where I ask students to explain a phenomenon or provide an argument, I look for students to bring in examples from areas outside of the one being tested directly. This is an extending level. Finally, I hammer out the criteria for emerging and developing. Typically, it depends on how much stuff I ask for is missing. If most of what I'm looking for is missing, then that's emerging or the bottom level. If 1 or 2 things are missing, then that's developing, that's the second level. For example, consider this rubric I have used to mark CER statements. First, a proficient CER statement starts with a definitive conclusion or argument and references data from the sources provided and provides a logical explanation that is grounded in scientific knowledge for the phenomenon. An extending CER statement would have everything under the proficient column, as well as a related outside example. A developing CER statement would have a definitive conclusion, but might not cite data or provide a logical explanation. And finally, an emerging CER statement would perhaps just have a definitive conclusion and nothing else. Let's see this rubric be used on a test question on evolution I gave my students this past year. I gave them this diagram on horse evolution, and I asked them one question. Is horse evolution an example of gradualism or punctuated equilibrium? Write an argument using the CER format. Now, a proficient CER statement would start with a definitive claim that horse evolution was an example of punctuated equilibrium. It would be followed by evidence. They would say that the table provided shows hundreds of thousands, if not millions of years between significant changes to the physical characteristics of the horse. And they would provide specific details. Followed by reasoning. They would say that these long stretches of no change was likely due to the environment remaining relatively unchanged for long periods of time, and therefore physical characteristics would remain unchanged. Now, an extending CR statement would include everything I just mentioned, but would also compare horse evolution to other cases of punctuated equilibrium. That's all the time we have for this episode. Please leave questions in the comments section below. And join me next time when I'll be sharing how I start my first day of school. I'll be sharing stuff that I used to do when I first started my career and stuff I do now. You don't want to miss it. Thanks for watching, and remember to science everywhere, every day.